going to sink to the bottom of the deepest part of the ocean on this 15-ton anchor from the Titanic. This will be one camera shot, so if you watch the whole journey, you'll understand how deep planet Earth gets, better than anyone who's just looked at a diagram or knows how many miles it is. We'll be falling at over 26 feet or 8 meters every second, which is the correct speed for this anchor, which is good because it means this normally extinct megalodon will struggle to catch us. Let's go. We start in the sunlight zone where photosynthesis works, so there is life and colour, fish, turtles, sharks, dolphins, and lots of Eiffel Towers stacked on top of each other to help us understand scale and speed. We're coming up to the twilight zone already, where there are no more plants as there's not enough light. And we're about to pass the deepest free dive ever by Herbert Nitsch. Blue whales, probably the largest animals that have ever lived, don't tend to dive much further than this, at levels where nuclear submarines are believed to operate. We just passed the deepest scuba dive ever as we drop below our first Eiffel Tower. It took Ahmed Garber 15 minutes to descend, but 14 hours to get back to the surface. We've been passing my wonderful Patreon supporters here. Do feel free to join them. You'll also find I've dropped giant ring lights down here every kilometre to make it brighter to help reduce something called thalassophobia, the fear of deep water. I get some of that due to a particularly wonderful film that slightly scarred me. But if we can see better, we can enjoy this journey into a vast part of planet Earth that hardly anyone has seen before. This is the record for the deepest dive in an atmospheric diving suit. Diving suits like that are like mini submersibles in the shape of a person, but the pressure is so high here that it's difficult to design them with enough dexterity to be useful. Before we leave the twilight zone, we need to witness the largest toothed predator on the planet. While giant squid are terrifyingly huge, they're no match for sperm whales. While a giant squid can scar a sperm whale with the hooks in its tentacles, an average adult sperm whale eats tens of thousands of giant squid in its lifetime, an average of more than one a day, which takes us to the midnight zone and the deepest dives of bottlenose dolphins and great white sharks. Now, if I switch off the lights for a moment, you'll see that many creatures here create their own light using bioluminescence. These videos take me a while to make, so if you don't want to miss the next one when it's ready, subscribing is probably the easiest way. The anglerfish is particularly interesting, using its light like a fishing rod to lure in prey. And this may be the longest animal in the world. At up to 50 meters, a giant siphonophore is considered an animal, but it's actually made of thousands of genetic clones that act as one creature. By the way, this is the film director James Cameron's deep-sea adventurer submersible. He was in this when he was the first solo person to reach the bottom of the deepest part of the ocean in 2012. That location is Challenger Deep, the same place we're sinking to now. While I descend further into the midnight zone, I'm already thinking about what's far below me, the abyssal zone. Nietzsche wrote, "If you gaze long enough into an abyss, the abyss also gazes into you." Wise words, because this is the largest eye on the planet, larger than my head. Its owner is the colossal squid, larger in weight than the giant squid and living deeper. Its giant eye is mainly for trying to spot those 50-ton sperm whales that love to hunt in the deep waters. Colossal squid are only found in the waters around Antarctica and are a good example of deep-sea gigantism, where some creatures are just bigger down here. Nobody has recorded a sperm whale attack a giant or colossal squid in deep water. However, in 2025, it looks like we got our first footage ever of a sperm whale emerging at the surface with a giant squid in its mouth. In fact, we're about to reach the deepest dive of another predator of deep-sea squid, although it's not strong enough to hunt an adult. We're approaching the deepest dive of an elephant seal. They are surprisingly huge. Isn't it crazy that a seal can get down this far. Elephant seals don't have echolocation. That's when dolphins and whales make a sharp, powerful click, then listen to it bounce off prey in the dark to find them. And seals don't have gigantic eyes either to be able to see glimpses of things like colossal squid do. So remarkably, elephant seals detect squid in the dark by feeling tiny vibrations in the water with their whiskers, which is beyond impressive. The deep oceans are full of so many adaptations and strange creatures, but the deep oceans are so poorly explored that we've never filmed the largest battle on the planet, sperm whales versus colossal or giant squid. There are some estimates that there are hundreds of millions of giant squid in the world, and sperm whales eat something like 3 million of them per day, and no one has ever seen that. We didn't even get our first footage of a live colossal squid, the largest invertebrate on the planet, until 2025. To an extent, this is due to a lack of funding and interest in the deep sea, but it's also because it's difficult to see down here and expensive to make submersibles that can survive the levels of pressure at these depths and beyond, which is where we have the depth record for the deepest diving mammal in the world, the Cuvier's beaked whale. It can hold its breath for about 3.5 hours while it dives down hunting for squid. As we say goodbye to the last of the mammals, I'd like to tell you my favourite fact about whales. We often think of evolution as this process where something similar to a fish climbed out of the sea, a bit like mud skippers do nowadays, finding life better above water, and naturally selected to lose their gills, develop bigger brains and stronger legs. It would be natural to assume whales never did that, staying in the water. But remarkably, whales are much more closely related to cows than sharks, because whales are descended from land mammals who left the water, then millions of years later, their ancestors went back in. This is why whales and every other mammal have to hold their breath underwater, which brings me to my favourite fact about whales. Whales have legs. Sort of. Tiny thigh and pelvic bones that float inside their body, not connected to their spine. They're used now to help make new whales. If you ever see a whale skeleton in a natural history museum, look for their teeny tiny internal leg and hip bones. Whales also have spindle neurons in their brains like humans, other great apes and elephants, which helps explain their complex reasoning and capacity for grief and joy. We're now about to zip past the most famous wreck in the world, the Titanic. It took around 2.5 hours to hit the bottom in 2 pieces. This is also the depth of the Titan submersible implosion in 2023. Titan was made with carbon fiber, and it seems that many warned them about how this was not the right material to use. I'll talk about pressure a bit later, but at 4 kilometres or 2.5 miles down, suffice it to say, the pressure here is incredible. And this is where we give our final gaze into the abyss to see what gazes back. We are now in the abyssal zone. I think there's a perception that the Titanic happened to sink at a spot that was particularly deep, but actually 83% of ocean floors are at this ridiculously deep zone. So the Titanic isn't particularly deep at all. All the creatures down here have had to adapt to the incredible pressure in different ways. For instance, these sea cucumbers have no gas-filled spaces in their bodies, and they accumulate special molecules that stop their proteins from being distorted by the pressure. They mostly survive on something called marine snow, dead matter from creatures above them, slowly falling to the bottom. In the abyss, it rains food. But there is one environment down here that is profoundly different to anywhere else on the planet. And if you can believe it, it has ramifications for our search for alien life. So in 1977, our understanding of life on Earth completely changed because of these deep-sea hydrothermal vents found in the midnight and abyssal zones, because the creatures found there did not rely on marine rain. They got their food via chemical reactions around these hot vents. When I first read about this, I didn't really understand why this was such an important discovery. Some bacteria and worms were found underwater. So what? The thing is, until this moment, it was believed that all ecosystems anywhere on the planet, from invertebrates to fish, amoebas, birds, fungi, mammals, trees, everything, they all get their energy from the sun. That might sound strange for us, or say a lion, but plants collect and condense energy from the sun. Then animals eat those plants, condensing some of that energy again into their own muscle and fat. Then other animals eat those animals, etc., etc. We can trace all energy from food everywhere on Earth back to the sun. All ecosystems on Earth are solar powered, or they were, until we found life in the absolute darkness of the abyss. We found an ecosystem built around chemosynthesis, bacteria that have evolved to feed on the chemicals in these vents, not sunlight, and animals that have evolved using that bacteria. It's difficult to overstate how amazing the ecosystem is here. The creatures here form symbiotic relationships with the bacteria. To give just 2 examples, these tube worms have an organ full of this bacteria inside them that turn the vent chemicals into sugar, pumping that into the worms as food. This Yeti crab has furry claws. That fur is actually bristles containing crops of bacteria. It waves them over the vents, feeding them like a farmer. Then they eat their crops. And of course, we have all the predators that feed on these animals. Finding them and other extremophiles meant something fundamental for the search for alien life, because it meant alien life doesn't need the power of their star. It might be able to thrive in darkness, underwater, or underground. Jupiter's moon Europa is covered in about 20 kilometres or 12 miles of water ice, protecting a sea underneath. That sea, we believe, contains more water than all the oceans of planet Earth. That's why these worms are so incredible, because they show us what might be out there, even in our own solar system. Now, we no longer need to worry about gazing into the abyss because we've just passed through it. But unfortunately, that means we're now in hell. Sort of. We're now in the Hadal Zone, named after Hades, the ancient Greek underworld where the souls of the dead go. So, what happens when you gaze into the underworld? What gazes back? I mentioned deep sea gigantism earlier, a process that makes deep water creatures bigger than normal. It even applies down here in the deepest zone, which means the biggest creature down here is about this big. The super giant amphipod. They're normally about 1 centimetre in size on the surface, so it's definitely bigger, but we don't currently know of anything larger down here, which is a relief. The pressure down here is so ridiculously high that it's genuinely difficult for creatures to be even this big. That's not to say there isn't anything else larger, we just haven't found it yet. I know there's been a lot of information in this video so far, but you don't need to remember it all. The main reason I made this was to truly experience a full journey to the bottom of the ocean. But along the way, I became fascinated with the stories down here, not the numbers. The millions of gigantic battles happening every day that we've never seen, or the crabs that think they're farmers that might help us find alien life. But there is one thing that I haven't really talked about yet that's really important to this world. Pressure. The deeper you go, the more water there is pushing down on you. But water pressure pushes around you too. It's a bit deceptive. This is an empty can. It quickly filled with water and sank down here. Water doesn't crush water, so this can won't be crushed, even to the bottom of the ocean. But if this can was sealed and had air inside, and I took it down with me, it would be squashed very quickly. Humans are a bit more like the full can than the empty one. We're mostly made of water, and water doesn't squash water much. But we do have some air inside us, mainly in our lungs. So, like that sealed can of air, as you descend, the increasingly heavy water pressure wants to crush it. If my magical spacesuit protecting me disappeared, my lungs and some of the inside of my skull would instantly implode. So I won't try that. In fact, if a normal human takes a breath and goes down to just 40 meters deep, their lungs might receive irreversible damage from the forces on them. Free divers like Herbert Nitsch avoid this by training themselves so that blood shifts around their chest, supporting their lungs, helping to stop them collapse, which is how he could get to 214 meters deep. Scuba divers, however, can go deeper because the air delivered from their tanks is at the same pressure as the water. If the pressures are equal, our lungs don't collapse, like the empty can. But this introduces other problems, the main being that when you go back up to the surface, if you don't do it really slowly, bubbles can form all through your body. This is called the bends. It's a bit like popping champagne. The cork holding in the pressure is removed and the dissolved gases inside the champagne form bubbles. Those bubbles can cause strokes and paralysis. Have you ever seen those YouTube videos where a Finnish guy called Lauri crushes almost anything, including a diamond, with a 300-ton hydraulic press? Well, if you made a 7-inch steel sealed box and took it to the depth I am right now, the crushing water pressure on it would be stronger than having 3 of those 300-ton hydraulic presses working at maximum power, squashing the box in 3 different directions at the same time. And we're not even at the bottom yet. This is why submersibles that can go all the way to Challenger Deep, the deepest part of the ocean where I am now, are an absolute marvel of engineering. Submersibles that go down to this depth and below need to be made of the strongest materials we have, like specialized steel. There is a problem with making submersibles fully out of steel though. It's hard to get them back up to the surface. You do not want to make it all the way to the bottom and then be stuck there. I'll explain how they solve that in a second, but we're about to reach a milestone for something that's a bit of a pet peeve of mine. You'll notice we're about to pass something that you might have heard often, but isn't quite correct. We're about to pass Mount Everest if you turned it upside down and dunked it into the Mariana Trench, where it won't touch the bottom. We'll pass it in a few seconds as I bring it in close. But this isn't really correct. Here it is. The thing is, every time someone draws a picture of the deepest point in the ocean, this location I'm in right now, Challenger Deep in the Mariana Trench, for some reason, they always seem to get 2 things wrong. Firstly, they draw a deep trench, which isn't actually accurate. The seabed for miles around me is an incredibly shallow slope. It's almost flat. Even when you get to the steeper walls a few miles away, they're only a few degrees, still a gentle slope. The second mistake is they always put in a picture of Everest upside down, showing that it doesn't touch the bottom, just like I just did. But I'm going to quickly explain why that's wrong and how we're going to fix it. It's wrong because Everest isn't a particularly tall mountain, which is obviously a pretty confusing sentence because it's the tallest mountain in the world, isn't it? Well, no, it's definitely not. Everest is the highest mountain in the world, not the tallest. Tallness is measured from the base of the mountain, height is measured from sea level. If you stand at the top of Everest, you do not become the tallest person on the planet. You become the highest. Everest itself, the image of it you often see, is only about 3.6 kilometres or 2.2 miles tall, which means we should have passed it back when I was talking about whales having legs. Mount Fuji, for instance, a particularly beautiful, but not particularly high mountain, is almost as tall as Mount Everest. But if you not only dunk Everest, but the entire Himalayan plateau of mountains that Everest sits on, then yes, a couple of minutes ago was when I would have passed it, which I think is even more impressive. That's how deep the Mariana Trench goes. So, how do they solve steel submersible sinking and not coming back up. James Cameron's Deep-Sea Challenger had a steel hull, but it was wrapped in something called syntactic foam, where millions of microscopic hollow glass spheres are suspended in resin. This makes a very strong and, crucially, very buoyant material, so that even at the bottom of Challenger Deep, it's still buoyant. It just needs to drop weights to get back to the surface. You might also be wondering what the actual tallest mountain in the world is and how far that comes down, and the answer is Mauna Kea in Hawaii, and we're about to pass its peak in a moment. This is the mountain we should be dunking in the Mariana Trench, but even the tallest mountain doesn't reach the bottom. You may not have heard of Mauna Kea, that's because most of it is underwater. But if you measure it from its base, it's 10 kilometres or 33,500 feet tall. It's almost 3 times taller than Everest. It is huge. But we're getting close to the bottom, and I'd like you to try and imagine something for me. Imagine you're on an international flight, looking out of the window. You may have experienced this before, and far below you, you see mountains, rivers, cities maybe. Well, try and imagine that your plane is actually a boat, and the air that you're skimming through is actually the surface of an ocean, with water so perfectly clear that the mountains and ground you see far below you is the seabed. That thing you're imagining, that distance, that's how deep Challenger Deep is. The distance between here and the surface is the same distance between the surface and long-haul plane flights. And you've just taken a journey all the way there. Isn't that incredible? Sea life is very sparse here compared to shallower levels, mainly highly specialized sea cucumbers, worms, crustaceans, and maybe some jellyfish. But it's still very much unexplored down at the seafloor, 7 miles or 11 kilometers from the surface. Eiffel Tower number 34. We arrived at Challenger Deep. Phew, that took a while. We are now at the opposite of the top of Mount Everest. We are at the bottom of planet Earth. But our journey isn't quite over. If you've watched this whole video, you should have a good appreciation of how ridiculously far we've come to reach the bottom of the world. But it would probably be helpful to do one last, slightly surprising thing to give ourselves a final sense of scale and wonder at how deep we are, because water just isn't see-through enough. So let's get rid of it. I'm going to drain just this section of the ocean by installing some giant cliffs, taller than even the tallest mountains in the world. I'm basically kind of recreating those diagrams of the Mariana Trench that I was complaining about before. Just remember, the Mariana Trench is a really gentle slope normally. This is very much not accurate now. But by doing this, it would at least now be possible for a human to walk along at the deepest point of the Earth. Except there's something really surprising about this location now: the temperature. When water was here a second ago, it was just above freezing. There's no significant heat from the ground below me, and because I've made this valley about 3 miles or 5 kilometers wide, the sun would rarely reach here. So it wouldn't be a crazy idea to think that it would be really cold down here. But it's not. It is boiling down here, and I mean that almost literally. It would be over 212 degrees Fahrenheit or 100 degrees Celsius, the temperature that water boils on the surface. The air pressure would be higher here, so water might not actually boil, even though it might reach 130 degrees Celsius down here on a warm day. This is all because air, unlike water, is happy to be squashed. The more air you have stacked, the more the air at the bottom is compressed, and the more you squash air, the hotter it gets. The opposite is also true. The higher you go in the atmosphere, the less air there is on top of you. Air that's less squashed is colder. That's why you can be on a hot beach in Hawaii and look up at snow-capped Mauna Kea, the real tallest mountain in the world. It's why lots of mountains are snow-capped in general. The air is less squashed up there, so there's less heat. Obviously, it's a bit more complex, and weather and latitude affect things as well, but generally, the higher you go, the colder you are. All of this means I'd rather get out of here and return to the wonderfully cool surface of planet Earth. I fill this man-made valley with hot air balloons and landmarks from around the world to help give one final sense of scale, and I'd like to get out of here as quickly as possible, so I'm hitching a ride on the largest rocket ship ever built. This is SpaceX's Starship, an engineering marvel that will be helping to take people back to the moon's surface again in the coming years. Isn't it incredible? Before I take off, one final example of the extreme pressure of Challenger Deep. If I lay James Cameron's Deep Sea Challenger on its side here to show you the kind of pressure it needs to resist at the bottom of the ocean, I can put weight on it to simulate the water pressure at this depth. It's not perfect because water pushes in from all directions at the same time, not just the two directions of above and below that we'll show here, but it's close enough to give you an idea of how strong this submersible needs to be. It would need to resist the force of 2 full-sized aircraft carriers balanced on top of it. 200,000 tons or 200 million kilograms. Deep sea submersibles are incredibly strong. Anyway, let's get out of here, shall we? It isn't very well known, but James Cameron confessed that he made the film Titanic, at the time the highest grossing film of all time, so that he could convince the studio to let him visit the real Titanic in a submersible. His true goal wasn't to make the film, it was to visit the shipwreck. He wrote an article about his deep dives and discoveries in the ocean and said, "Nothing the artifice of Hollywood has to offer can compete with the thrill of something this exciting and 100% real." I like those words. Science is often a fascinating adventure of discovery, but it's the best kind of adventure because it's real. He and his team discovered at least 68 new species in his dives down to Deep Sea Challenger. 68 species of life no human had ever seen before, and I love that he used art to fund science. I think they go together so well. There's so much for us to discover in the universe, whether it's life beyond Earth or curing diseases, colliding black holes, or sperm whales colliding with giant squid. Curiosity, science, engineering, collaboration, and adventure can take us to the bottom of the world or leave it completely. It can take us almost anywhere, find the secrets of almost anything. I think it's exciting to imagine a future when we know all the secrets of our world and the universe. But if researching this video has taught me anything, it's that we are so lucky to live in a time where so much science is taking place, including under the sea. So much of the universe is still to be discovered. In short, we still have so many scientific adventures still to go on. And they're the best kind of adventures because they're real. Thank you for watching my video on Challenger Deep, the deepest part of our ocean. A huge thank you to Brilliant for sponsoring it. So you'll know from the intro to this video that I don't use any generative AI to make my videos. I really don't like it, which is why I use 3D animation, real footage of my face, as well as motion capture, which is what all these balls are for. I couldn't do fingers for this video, which is why I looked a bit karate choppy for this one. AI is really powerful, but I want AI to help us make things, not make things for us. Creativity isn't a problem that needs fixing. This applies to education too in a different way, because a lot of kids are using AI to do their homework for them, so they don't learn anything, which is why I'm really impressed with the sponsor of this video, Brilliant. If you're a parent and want your kids to learn mathematics or coding, they've found a way to use AI the right way. They've made an AI tutor for students in 5th grade through college. Their tutor is called Koji. The crucial thing is, it's not built to answer questions, it's built to ask them, guiding students step by step, breaking down tough problems, even drawing on their screen to make sure they understand each concept before moving on. I wish I'd had a tutor like this when I was a kid. Using AI to help kids learn is a great example of how to use this technology. So if you have kids who could do with their own personal tutor, click the link below or scan the QR code to get started with Brilliant's tutor for free. You can upgrade to premium to unlock all courses. And right now, Epic Spaceman viewers can save 20% off an annual subscription at brilliant.org/Epic Spaceman. Thanks again for watching my video on the deepest part of the ocean. I'm sorry this one took me so long to make, but I'll be getting the next few videos out more regularly. So, see you soon for another epic space map video. Cheers.